Welcome to the solutions for the Chapter 5 test part 2. Number 1, we wanted to find the exact value of the sine of 11 pi over 12. Well, when we look at our unit circle, you'll see that there's no special angle at 11 pi over 12. So we have a choice. We could either use a sum or difference, or we could use the half-angled formula. Now, either of those will give you the correct answer if done appropriately. They may look a little different, but if you type in the calculator, you'll see that they are equal. I find it a little easier to use the sum and difference. Now, since some of you aren't really good working with fractions that equal 11 pi over 12, let's go ahead and change 11 pi over 12 into degrees. We know we could do that by multiplying by 180 degrees over pi. Notice I didn't put pi in the calculator since the pi's cancel, and I get 165 degrees. So how could I rewrite 165 degrees either as a sum or a difference of special angles on the triangle? Well, for this video, I'm going to use 120 degrees plus 45. So that means I'm going to need to use the sum formula for sine. So I know that the sine of u plus v is equal to sine u cosine v plus cosine u sine v. So now I'll go ahead and substitute the 120 degrees and the 45 degrees. So I get sine of 120 degrees cosine of 45 plus cosine of 120 degrees sine of 45. Now these numbers I'm getting right from the unit circle. Well, actually I'm getting it from my memory, but feel free to look at the unit circle as we go along. The sine of 120 degrees is radical 3 over 2. The cosine of 45 degrees is radical 2 over 2. The cosine of 120 degrees is negative 1/2. And the sine of 45 degrees is radical 2 over 2. So I go ahead and multiply these. Radical 3 times radical 2 is radical 6. I get a 4 there. Here, I get negative radical 2 on the top and 4 on the bottom. So I could rewrite this as the quantity radical 6 minus radical 2 all over 4. Okay, for number 2, I asked for the general solution of this trigonometric equation. So first we can look on the unit circle and find, well, when is cosine of theta equal to negative 1/2? And we find that there's two values on the unit circle where cosine is equal to negative 1/2 at 2 pi over 3 and at 4 pi over 3. So if the question was solve an interval from 0 to 2 pi, these would be your solutions. But we know that there's an infinite number of solutions to this equation, so we can write that by including the period 2 pi times n, where n is an integer. Now this n is an integer. I'm not going to require you to do it, but just realize that that's really what we're saying. So these would be my general solutions to that problem. Okay, number 3, the sine of 3x is equal to negative radical 2 over 2. So what we first can figure out, well, when on the unit circle is sine equal to negative radical 2 over 2? And we'll set that equal to 3x. So sine is equal to negative radical 2 over 2 at 5 pi over 4 and at 7 pi over 4. But because of the 3x, there's going to be more than 2 solutions. In fact, there'll be 6 solutions. So the other equations that we're going to solve involve adding 2 pi. This kind of goes back to the general solution where we added 2 pi n, except we're just going to add 2 more pairs of solutions. Excuse me here. So when I add 2 pi to 2 pi, I get 4 pi. And I go ahead and solve. So here I divide both sides by 3. 3x equals 5 pi over 12. Sorry, not 3x. X. Here I divide both sides by 3, and I get 7 pi over 12. If you're not understanding how I'm getting these answers, I'm just going to do one quick example. So when I divide both sides by 3, obviously that's x, but over here what I'm really getting is 7 pi over 4 times the reciprocal of the denominator. Well, the reciprocal of 3 is 1/3. 7 pi times 1 is 7 pi, and 4 times 3 is 12. So here, if I add 2 pi to 5 pi over 4, I get 13 pi over 4. So when I divide both sides by 3, I get 13 pi over 12. Here, so I'm going to add 2 pi. That gives me 15 pi over 12. And I know that 3 goes into both these, which gives me 5 pi over 4. X equals 21 pi over 12, or 7 pi over 4. And for the last one, I get 23 pi over 12. Okay, number 4, we've got 2 cosine theta plus radical 3 is equal to 0. So we want to get the cosine theta by itself. We'll subtract radical 3 from both sides. And then we'll divide both sides by 2. Since it's just asking for the solutions in the interval from 0 to 2 pi, just look on the unit circle. When is the x-coordinate equal to negative radical 3 over 2? And your answers are 5 pi over 6 and 7 pi over 6. Okay, number 5. Well, if we use the zero product property, and we can use that when we have 0 on one side of the equation, is we can split up the factors and set them equal to 0. So when is sine x equal to 0, and when is cosine x equal to 0? Now, on my instructions, the interval for the solutions was 0 to 2 pi. The bracket means that 0 is in that interval. The parentheses on the right means that 2 pi is not in the interval. So some of you are giving me answers of 2 pi rather than 0. Some of you put both 0 and 2 pi in some of the solutions. So for sine x equals 0, it's the y-coordinate is 0 at 0 and pi. And then for cosine, it's equal to 0 at pi over 2 and 3 pi over 2. I saw some student change this into a double angle formula for sine, and it does work also. So number 6, we're solving again for the trig function. Most of you did the first step really well, dividing both sides by 3. And then most of you realize that you need to take the square root of both sides. What some of you forgot is to include both the positive and negative roots. Now you probably won't see this number as is on your unit circle. So we know that radical 1 is 1, and we get 1 over square root 3. And then we rationalize it by multiplying by 1. And we get plus or minus radical 3 over 3. So looking at our unit circle, when is tangent equal to either positive radical 3 over 3 or negative radical 3 over 3? And your solutions are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Number 7. We see we can factor out a sine x. And now we can set each factor equal to 0. So for sine x equals 0, we solved that from above. Sine is 0 at 0 and pi. Now, when we try to solve this, we get sine x squared equals negative 1. Now, if you take the square root of both sides, you're going to get an imaginary answer for x, or actually for sine of x. So there's no solution for that equation. Our only solutions are 0 and pi. Number 8. The biggest mistake I saw is people added 2 to both sides and then tried to factor the left side. Well, that's not going to work because the zero product property only works if one side of the equation is equal to 0. Now, if we just had cosecant x, yeah, we want to add 2 to both sides, but we have a cosecant and a cosecant squared term. So first, see if you can factor. Remember, this is just like negative 1 cosecant x. So can we find two numbers that multiply to negative 2 and add up to negative 1? Well, I'm getting negative 2 and positive 1. Now we can set each factor equal to 0. So here, now I can add 2 to both sides. And I get cosecant x equals negative 2. So what I'm going to do is I'm going to take the reciprocal of both sides, and I get sine x equals negative 1/2. Well, looking at the unit circle, I know that sine is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. Here, I'll subtract 1 from both sides. I'll take the reciprocal of both sides, and I get sine x equals negative 1. Looking at the unit circle, I see sine is negative 1 at 3 pi over 2. Number 9, cotangent theta is equal to negative radical 3. Well, since most of you probably don't have cotangent written on your circle, you just take the reciprocal of both sides. The reciprocal of cotangent is tangent equals negative 1 over radical 3. So we can multiply both sides by, both the top and bottom by radical 3 over, multiply both sides by radical 3, the top and bottom, and I get negative radical 3 over 3. So hopefully you've written those under unit circle, and our solutions are 5 pi over 6 and 11 pi over 6. Okay, number 10, we can go ahead and factor sine x. And we get sine x plus 4 inside the parentheses. And we go ahead and set each factor equal to 0. So we know sine is 0 at 0 and pi. Now we saw the other one, we get sine x equals negative 4. Well, the range of sine is between negative 1 and 1, so there's no solution to that one. 0 and pi are the solutions. Okay, I have some sad news about number 11. For whatever reason, the thing I photocopied actually had the wrong formula. Not the wrong formula, the formula was just incorrect for this problem. So I'm going to show you with the correct formula. Just realize that this is not going to match the one that you saw or that you have on your sheet. So you can go ahead and fix this if you'd like. The formula we need to use is that, the cosine of u times the sine of v is equal to 1/2, this part was right, the sine of u plus v minus the sine of u minus v. That's what it should be. So for this problem, my u would be 3 theta, and my v would be 7 theta. So I get 4 times 1/2 of sine of 3 theta plus 7 theta minus sine of 3 theta minus 7 theta. So 4 times 1/2 gives me 2, and I get sine of 10 theta. Oops. Let's try it again. 10 theta minus sine of negative 4 theta. Now, if you wrote this as your answer, I would accept this. Some of you didn't distribute the 2. This would have gotten you full credit for this problem. But since I know that sine is an odd function, I could rewrite this as 2 sine of 10 theta plus 2 sine of 4 theta. Okay, our last problem, number 12. Here is the formula you should have used. So my u is going to be 5x, my v is going to be 8x, and I go ahead and substitute. So I get sine of 5x plus 8x over 2. Over here I get sine of 5x minus 2. So simplifying, I get sine of 13x over 2 and sine of negative 3x over 2. Now, like the last problem, I would have accepted this for full credit, but since I know that sine is an odd function, I could pull this negative out, making this essentially a positive. And there's how I can write my final answer. Thank you for watching. I hope it's been helpful.